As we said before, theoretical yield is the maximum amount of product that one can make, theoretically can make, based on the limiting reactant, based on the reactant that will run out before other reactants. So this theoretical yield can be calculated either based on moles or grams. It can be expressed either in moles of the product or grams of the product, and it doesn't really matter. So let's use an example of the reaction that we worked with before in the previous session. We wrote a balanced reaction equation for this reaction as calcium carbonate, C plus 2HCl. It has to be correctly balanced, otherwise none of these calculations will work correctly for you. Okay, so we wrote this earlier in the previous session. We also in the previous session determined that based on the amounts we were using of calcium carbonate and hydrochloric acid, which by the way we should remind ourselves, these amounts we used 28.4 grams of calcium carbonate and 9.45 grams of HCl. Based on these amounts of the two reactants used, we also determined in the previous session that hydrochloric acid HCl was the limiting reactant. Please, if you have any concerns about these, go back to the previous session and review the work that we did together. Okay, so as we said before, theoretical yield is the maximum amount of product that you can produce from the limiting reactant. So in this case, we need to calculate the theoretical yield of calcium chloride in this, given these amounts of the reactants. So since HCl is the limiting reactant, we really only care about the amount of HCl because that is the one that will control, that is the one that will determine the maximum amount of calcium chloride that we can get from this reaction. So basically what we are doing is converting grams of HCl all the way to grams of CaCl2. Please go ahead, pause the recording while you set up this conversion and calculate the answer. So grams of HCl can be converted into moles of HCl using molar mass of HCl. Moles of HCl can be converted into moles of calcium chloride based on the balanced reaction equation that we are working with, and that can then be converted into grams of calcium chloride based on the molar mass of calcium chloride, 110.98 grams. That should not be crossed out. It's the moles that crossed out. When you calculate this and you round your answer to 3 significant figures based on that number, we get 14.4 grams of calcium chloride. Basically, the maximum grams of calcium chloride that is possible given these amounts of the reactants in this reaction is 14.4 grams of CaCl2. That is the max we can get. Okay, let's try it out again for a different problem. Here is a reaction. Equation is given, and we are given also the amounts of reactants being used. What's the first step in this process? Balance the equation. Please go ahead, do that. When you balance the equation, hopefully your balanced coefficients match mine. Okay, next step. What is the next step? Next step is for us to figure, so first step is to balance the reaction equation. The next step is for us to figure out the limiting reactant. And if you remember, in the process of figuring out the limiting reactant, there are several steps. We have to select a product that we are going to work with in order to determine the limiting reactant. Now, in the previous session, I said that it really doesn't matter which product you select to work with. However, sometimes it is more convenient to select one product over the other. In this particular case, since they're asking us for the theoretical yield of titanium, maybe that's the product that we should select and make the whole process more convenient for us. So we're going to select titanium. And then, of course, after that, in order to figure out the limiting reactant, you have to calculate the number of moles of titanium, the selected product, we can get from each of the reactants separately. So in other words, we need to convert 9 point, excuse me, not 9 point, 965 grams of titanium for chloride into moles of titanium, and we also need to convert 480 grams of sodium into moles of titanium as well. Please go ahead. You already know how to do this. Pause the recording while you complete the setup and the calculation. Okay. Moles of TiCl4, 189.67 grams. That's the molar mass. And then 1 mole of titanium for 1 mole of TiCl4 from the balanced reaction equation gives us 5.087784046 moles of titanium. Now I'm not going to round off at this step because we have more calculations to do. When you do have a process like this, please, as I've said before, round only at the end based on the data given. So we are not at the end, so I'm going to hold off on the rounding. Moles of sodium, and then 4 moles of sodium for 1 mole of titanium. When you calculate this, we get 5.219660722 moles of titanium. Based on these numbers, the limiting reactant is titanium 4 chloride, TiCl4, and based on the limiting reactant, we can therefore determine the theoretical yield. Now, theoretical yield is that of the product. So the maximum number of moles of the product we can get in this reaction is 5.087784046 moles of titanium. So to calculate the theoretical yield, unless of course theoretical yield can be in moles, in that case this will be the theoretical yield, or theoretical yield can also be in grams, which means that we take those many moles of the product from the limiting reactant and convert that into grams of that product. So in this case, we get an answer of 243.5522223 grams, and that rounded to 3 significant figures gives us 244 grams of titanium. So once again, as I said before, theoretical yield can either be given in terms of moles, in which case it would be in 3 significant figures, 5.09 moles of titanium, or it can be given in terms of grams, in the correct number of significant figures. The only word of caution here that I would give to you is if you are going to grams, if you are doing more calculations as needed, then you must hold off your rounding till the very end.